Morning, everyone. We'll make a start. So thanks to those in the room and those that are joining us online. So this event is something that Amelia Carr and I have discussed for a little while now. She's here for a 1 month period as an IAS fellow, and that is mainly to foster collaboration between us and Deakin. And so the idea of this event was there's a significant interest in female performance physiology at Deakin and also here. Sam Rowland was meant to be leading this, I'll be completely honest, so I'm subbing in for her, and it's something that her and Amelia have discussed. The idea is perhaps an idea of the type of work going on here at Loughborough and at Deakin. Amelia and I will then put together almost an information pack of the different researchers that are here and in Deakin, both staff and PhD students, to circulate between the two universities so that you guys can go away and think about people that might be good to collaborate with. It may be for PhD students, it might be helpful to link with somebody that's doing something similar or somebody who's got experience in the area that you're working with, and maybe hopefully foster long-term collaborations in the same way Amelia and Ian Taylor, Amelia and Sam are working together. Okay, so here's a map, Loughborough to Melbourne. This is the trip that Amelia's gone on.
Oh, sorry, I need to put them on.
Perfect. We have 4 people from Loughborough, all PhD students listed here, who will present first of all, then 4 people from Deakin. Now, we're going to be strict on time. We kind of said this up front, so we really need you to stick to 3 minutes. Those of you that will present in the room, I'll start waving at you if you get to 3 minutes. So if you can just wrap up then, that would be great. Everyone's only got 1 slide, so we're hoping we shouldn't go over time. And then we've got 4 presenters from Deakin who Amelia is going to keep in check. There will be time for 1 question after each talk, but there is also coffee and biscuits. Kieran?
Yes.
Yeah. For those that have attended in person, there's coffee and biscuits afterwards. Those online, you can eat your own biscuits and make your own coffee, sorry. But this is the running order. However, before we start, I'd like to do a little bit of a history lesson. So whilst there is a Melbourne in Australia, the original Melbourne actually is only 13 miles from Loughborough. Don't know if you knew this, Amelia. Don't know if those in Deakin knew this. So what I thought, I regularly cycle through here. If you're a cyclist, you'll cycle through Melbourne. I don't know if Lee Taylor's online, but he used to live in Melbourne. And so I thought what would be really nice is to kind of see how the new Melbourne in Australia, as we'll call it, and current Melbourne or the old Melbourne have some similarities. Some of these are mine, some of these are AI. The first one is population, very, very similar population. Melbourne, Victoria, 5.3 million. Melbourne, Derbyshire, 5,000. Second one is apparently prominent large water features. This is Melbourne, Australia, beautiful bayfront. You can see yachts here, the skyline of the kind of main city there, beaches. And this is Melbourne, Derbyshire. And you can tell they have this is AI, this one wasn't me. Apparently this is a similarity between the two. You can tell by the size of the yachts being the same as the size of the duck on the right hand side that the scale is about the same. The next one is cricket grounds. So Melbourne, Australia, you have this average cricket ground. Melbourne, Derbyshire, the original Melbourne has this Melbourne cricket ground. The only discernible difference that I could see was the branding, so I've added that, and now they're even more similar. But apparently, the one real similarity is coffee culture, which in Melbourne, Australia, I'm told is a massive part of the lifestyle there. You have these like swaths of bars and streets with coffee shops and the like on. I've never been. Melbourne, Derbyshire, you have the same sort of coffee culture. It's beautiful coffee shops that are available to go and drink in. Apparently, actually, they do have really nice coffee shops in Melbourne, Derbyshire. So I think this is actually the one similarity, and that's nutrition and physiology, caffeine. And so that's what we're going to talk about today. So I thought that was a nice one to leave on. Okay, I'm going to let the speakers introduce themselves. But up first, we have Hannah Smallwood. So Hannah, do you want to come forwards? Where are you? There. Oh, actually, sorry. Amelia. Amelia's going to introduce, sorry, Hannah. Amelia's going to introduce Deakin and talk a little bit about their research group.
Thanks very much, Lewis. Really enjoyed the history lesson. We definitely need to get you to Melbourne to experience in firsthand a comparison between the coffee culture. So thank you everyone for joining today. I'm partway through my IAS visit and I've had the most fantastic time so far due to the amazing support from IAS, but also this ability and opportunity to meet like-minded researchers and PhD students and academics. It's been really amazing. So the reason that we've set up today, the way that we have, as was said, is to expand that opportunity for those at Deakin and at Loughborough. So to briefly introduce everybody who's presenting today from Deakin is part of our School of Exercise and Nutrition Sciences and also our Female Physiology and Performance Initiative. So this is a group of people open to anyone across our school who's interested in female-specific research to advance work in physiology and performance in sport and exercise and occupational contexts, and also to produce research outputs and outcomes that can be beneficial to women and girls. So that's our mission. And we're looking forward to sharing some of our research, but now I'll hand over to the Loughborough presenters and looking forward to hearing more about your research.
Now, Hannah. So I thought it would be quite nice if a question that is after each of the presenters comes from Deakin, and likewise when the Deakin presenters present, the question that's specifically asked them comes from Loughborough. So we're going to manage that online, right? So yeah. Right, over to you, Hannah.
Is it just the middle one? No.
Right hand one.
Yeah, I think that makes sense. Hi, okay, my name is Hannah and this is the first study of my PhD and I'm looking at exercise performance, gut comfort and gut function when exercising in heat in women. So gastrointestinal symptoms are really common in athletes from a recreational to an elite level. Up to 70% of athletes suffer from them. They can be really minor symptoms such as flatulence or belching, but it can be detrimental to performance, for example, vomiting, diarrhea, nausea. And anecdotally, it appears that women are suffering from these more frequently and more severely than men. We don't quite know why. We also know that heat really drives gastrointestinal dysfunction. So we're essentially looking at whether endogenous and or exogenous female sex hormones is driving the disruption to the gut and causing these symptoms. This is really important because people are exercising the heat more and Glide coming up. So maybe for the Aussies it would be okay, but I think for the Brits it might struggle. So our aim is to have 30 participants. A half are going to be menstrually cycling, having a menstrual cycle, and the other half are going to have an oral contraceptive pill. We're currently on around 9 of the menstrual cycle and 6 of the OCP. They're all young, fit, healthy, and have a running background. So it consists of 3 visits to the lab. The first is a preliminary trial, so just maximal, submaximal testing alongside familiarization in the heat. And then we basically randomly order the experimental trials between, if it's a menstruating participant, between the early blinking phase and the mid-luteal phase, or if they're on the pill, between the off or inactive and the on active phase. So they come in, do baseline measures, and then they run for 90 minutes in the heat, but they're actually in the chamber for about 2 hours. So it's set to about 34 degrees and 40% humidity, and they do 6 15-minute bouts at about 65% humidity max. And then immediately 1 hour post and 2 hour post, we again take various measures. So some of the key measures we're taking, I suppose, are IFAB and then the lactulose rhamnose ratio. So these are really good markers of gut permeability and gut damage, alongside some more subjective measures. And then we're also measuring wider physiological responses to exercise and heat. Essentially just trying to paint a picture of what's happening for women. So yeah, that's my research.
Excellent timing as well, Hannah.
Oh, great.
Do we have any questions from Deakin for Hannah? You can just unmute your microphone if you've got a question.
Tell me to raise a hand and I'll unmute them. But
Okay, yeah. I'll have a question to start with. So, I noticed that you made some comments about differences between Australia and the UK in terms of heat exposure. I was just wondering, with your criteria, when you've got you're selecting your participants, have you ever had a situation where you've needed to screen for heat acclimation? Do you ever have participants who've been exposed to the heat because they're exposed to quite high levels of heat and humidity in your experiments?
So we don't make it a set criteria, but we do ask if they've had a prolonged period of heat in the recent months. We've not had anyone yet, and also because a lot of testing has been in winter, and they've been pretty safe if they've been in England. But yeah, we've not had anyone yet.
Okay.
Had that heat exposure.
Thank you. I think it's time for our next presenter. Thank you so much.
Up next is Chloe Knight.
Making sure everyone online can hear me as well. So up next, we've got Chloe McKnight, who's going to present what she's doing for her first study that started very recently, or is starting very recently. Yeah, not started yet.
Okay, hi everyone. If you don't know me, I'm Chloe. I'm a postgrad teaching assistant and part-time doctoral researcher here at Loughborough. The presentation is going to be a brief overview of my PhD topic, and then the plan for study one of data collection will begin in a few weeks' time. So exercise-induced muscle damage, or EIMD, it doesn't have a definitive definition, but it typically refers to the signs and symptoms that can manifest in muscle in the days following a novel or strenuous exercise. Eccentric exercise typically causes the most damage due to the fact that the muscle is consistently contracting when lengthening, which increases the mechanical strain on fibers. Precise etiology isn't well known, but it is believed to occur in a biphasic manner. So the exercise itself causes primary muscle damage, and then the subsequent inflammatory response causes secondary muscle damage. The image on the screen shows the histological changes at a fiber level. So damage is evidenced in the extracellular matrix, the membrane, and the sarcomeres. This can be assessed both directly through looking at muscle fiber necrosis, or more commonly indirectly. So looking at neuromuscular function, blood markers, urine markers, and subjective scales. Estrogen is believed to have a potentially protective effect against muscle damage due to its antioxidant structure and properties. This causes an increase in membrane stability and a reduced inflammatory response. There's strong evidence for this in animal models and cell culture models, but the evidence in humans is a lot more contradictory. This is largely due to the variety of methodologies employed, the lack of broad spectrum markers that are assessed within the same population group, and the multitude of hormonal environments that women can experience due to increased contraceptive types. Most studies tend to look at sex-based differences rather than estrogen. So my thesis aims to determine if there are any differences in exercise-induced muscle damage recovery due to these different estrogen concentrations. The way study one will do this is following a familiarisation. A damage and exercise protocol will be employed, and then indirect markers will be assessed pre, immediately post, 24, 48, and 72 hours post-damage to fully encompass the recovery. This will be done using independent groups, so contraceptive users will represent our chronically low estrogen group, and natural menstruators tested just prior to ovulation will represent high estrogen. These groups have been chosen as we believe it represents both ends of the estrogen spectrum and also minimises the chance of the repeated bout effect having an impact if we were to do a repeated measures design. Studies in users and non-users of muscle damage have been done before, but we aim to improve on the current research based on 3 key ways. The first is by increasing the sample size. This will increase the statistical power of our study, allowing us to detect any changes should there be any present. Secondly, we look to increase the number of markers assessed within the same population group from both an objective and subjective perspective to truly encompass recovery as a whole. And finally, we look to account for menstrual cycle symptoms, as it is believed that symptoms experienced by women can negatively impact the way that they perceive their recovery from muscle damage. So it's important to consider this as well. Thank you for listening.
Thanks so much, Chloe. Any questions from Deakin? I have one. Could you tell us about, you mentioned that you've got your subjective measures as well, and just a bit more about how you think these subjective and objective measures might interact to tell you sort of more completely about the effects you're observing?
Yeah, so the objective measures we'll look at is mainly neuromuscular function, because that's the gold standard for assessing muscle damage. And then blood markers and urine markers will assess a whole wide range from intramuscular proteins to inflammatory markers. With the subjective side, we use the classic delayed onset muscle soreness using a visual analog scale. We'll account for menstrual cycle symptoms, so participants will complete a questionnaire in every single visit that they do. And then we'll also look at pain pressure threshold, which is a subjective measure that essentially helps us detect when they feel their first sensation of pain. We expect that obviously the subjective measures will correlate with the objective measures. But the evidence that's currently out there is very contradictory. So titin can correlate quite well with neuromuscular function, but not as well with creatine kinase. And then DOMs can correlate with creatine kinase, but not titin as well. So whether we actually see a correlation will be interesting, because the current research out there is a correlation do exist between the objective and subjective.
Thank you. Very comprehensive. Appreciate it. Thank you.
Next slide. Up next.
So basically my research is a little bit different to everyone else's. It's more basically cell culture based, so it's all in the cell culture lab. But basically my aim is to create specific models of skeletal muscle, but in cell culture. So obviously we all are probably very aware of the big differences between female and male muscle on a physiological scale, in terms of metabolism, protein expression. Here are a few of the differences. Obviously, we know there are. Is that particularly in preclinical testing, most models are male-only cells or they'll just use animal cells. So essentially, there's a big gap where we're not testing on female-specific muscle models. So this is essentially what I'm aiming to do, particularly as a lot of females we seem to see more adverse effects after when enter clinical trialing. So this kind of highlights why it's essential that I build this kind of female-specific model. So obviously the main aim is to create this female-specific muscle model, but also to use testing as a form for potentially looking at things that we can't necessarily model in vivo. So pregnancy, we don't necessarily want to put a pregnant person into a heat chamber. It's quite a kind of horrible environment for that. So potentially we can look at using cell models for that. Things like injury responses in females versus males, extreme nutrition deficits, that kind of thing, as well as transgender thing. So the way that I'm this is via switching serum between males and females, looking at how the morphology of muscle may change based off this, also dosing with hormones, specifically seeing whether a lot of these skeletal muscle differences are driven by hormones themselves or by biological sex. So a lot of my experimentation will look at swapping these hormones between male and female muscle, looking at the perfect dose, try to create female and male skeletal muscle models. And then the final step is basically to validate this against female and male whole muscle samples and single fibers. So a lot of my analysis is very fluorescent based. So looking at muscle morphology and how female and male muscle again is different and how I can replicate this in culture. Looking at basically these are typed fibers, so these are type 2 fibers, type 1 fibers, and seeing how these again differ between male and females. And whether the protein analysis I take from this whole muscle is then replicated in the muscle models that I can create in culture. So yeah, that's essentially my research.
It was
Great.
Any questions to start off with from Deakin? Sev? Yeah, so we've got a question from Severine Lemon, who's one of our executive members for our Female Physiology and Performance Initiative. Hi,
Yeah,
Sev.
hi. Hi, everyone. My question is, it's not a question, and I hate saying that because, Amelia, I know what you think about people making comments rather than questions. But this week, we've actually published a large-scale transcriptomic analysis of human skeletal muscle primary cell lines, comparing 30 cell lines with the phenotype of their primary donors, whether they're male, female, young, or old. And I think you might be interested in the results. It's been on PubMed for a whole 48 hours. And basically, it does completely validate your hypothesis that phenotype is mostly lost in culture for 99.9% of the genes that we've examined using high throughput RNA sequencing. And there's a few other results that you might be interested in. So if you want to talk about it, get in touch with me. Yeah, that's it.
Thank you so much, Seb. And we've got time for one more from Andrew, who's Andrew Bertick is also part of our executive for female physiology and performance. Hi, Andrew.
Hi, on the back of Severine's comment there, I was just wondering, so, and let's assume I know nothing, which isn't too far from the truth, but when you can manipulate in cell culture, say the hormones or the types of hormones and all the derivatives of the hormones, but how do you get the balance between the hormones and the receptors? And can you get I guess, can you play around with let's say a male phenotype fiber and also modify it to have levels of receptors similar that in a female fiber, and kind of play around with that? Just curious.
Yeah.
Just
So
curiosity.
so that's something we're actually looking at as well, is estrogen receptors and androgen receptors. So firstly, figuring out the baseline levels of those, and then whether they are differentially altered when you dose male cells with estrogen or whether you dose female cells with estrogen. So that's one of my kind of like chapters of my PhD. We'll also be looking at receptor stuff related to like hormone dosing at baseline and after dosing, basically. So yeah, not sure yet.
Awesome. Good luck.
Thanks, Andrew. So we'll move on to our next presenter. Thanks so much, Emily.
Last but not least, Charlotte Donat. Final presenter. Thank you, Charlotte.
So my study is a little bit different because it's kind of like clinical trials. So as we know, as we get older, things like cardiovascular function are seen to decrease, exercise capacity decreases, and there's more risk of kind of metabolic dysfunction. So basically, I'm looking at the effect of a supplement called cardiosesperidin, which is derived from Spanish sweet oranges. So my study population is specifically older adults, so 50 to 70-year-olds is the criteria, but I've tried to prioritize over 60s. So basically, I've got pretty much an even number of men and women, and they come in several times over the course of the study because it's a double-blinded crossover design. So they come in for familiarization, and then it's testing at baseline, which is week 0. After 8 weeks of supplementation with either the supplement or the placebo, a 4-week washout, and then whichever one they weren't on first. It's also good because it means even if the supplement doesn't do anything, we hope it does because there's been kind of findings in preclinical models and some human clinical trials. It means we've also got a good amount of baseline data on how these measures vary in postmenopausal women and men. So basically the visits are kind of 2 days. So in the first day, it's more of kind of the exercise day. So it's body composition measures, using the isokinetic dynamometer for muscle force testing and a ramp test on the bike. The second day is more vascular. So we look at blood pressure, central and peripheral. So using a tonometer as well, it's just a normal blood pressure cuff. FMD, which is the best indirect way to measure the health of the brachial artery, is our kind of major measure of vascular function. And then we take a blood sample and do a muscle biopsy, which with freezing some of it, we'll later analyse for various biomarkers. But immediately after, I use something called an Ouroboros to look at kind of mitochondrial capacity and see if this is very by the supplement, and also if there's much of a difference in the male and the female. muscle. So yeah, I don't know where I'm at on time, but that's kind of like a crash course through what I'm actually doing.
Okay, questions for Deakin, for Charlotte? Charlie. Hi, Charlie. I think you just need to unmute your microphone, Charlie.
Sorry, rookie error. Hopefully you can hear me now. Thanks, Charlotte. That's really interesting. This might be obvious. Can you explain why specifically we might expect this would be of interest or useful for older adults? And is there any information on other population groups?
Yeah, so the main reason for looking at older adults is obviously we've got an aging population, I think, in most areas of the world, and obviously a lot of the things I just listed, so cardiovascular function, metabolic diseases, muscle dysfunction, exercise capacity going down. There is a lot of literature showing obviously that corresponds with aging. So there have been some studies done using this supplement and also hesperidin in different forms and oranges in other populations. But I think the idea is that this would almost be the population that if we do see a positive effect, it would have the most positive impact on, because hopefully it would maybe delay the date. Like if someone's going to suffer from these kind of things, it would maybe push back when that instance occurs. And like say with the population being aging, we want to try and push that back as long as we can from like a public health perspective, but then also just for someone's general kind of health. And yeah.
Right, thank you, Charlie, and thanks so much, Charlotte. Thank you very much to our four LUFRA presenters. We'll now move into our Deakin presentation. So I will introduce our first presenter. So Annabelle Critchlow will present our first talk, and the title of her presentation is The Role of Estrogen in Female Muscle Aging. Thanks, Annabelle.
Thank you, Amelia. So hopefully you can hear me. Okay, so thanks for having me. So it's well established by now that aging leads to a significant loss of muscle mass and function. And this leads to a whole host of poor outcomes, such as a lack of functional independence, low quality of life, and most importantly, increased mortality. So, but on top of this, females also have to go through menopause as well. So they experience drastic changes to their circulating sex hormone levels, like estrogen and progesterone. But we typically think of these hormones as being involved in reproduction, but they also act in all of the tissues around the body, including skeletal muscle. So it's really important for us to understand how menopause-induced changes could also impact and worsen age-related muscle wasting as well. So the overarching aim of my PhD work was to investigate whether circulating estrogen levels were associated with muscle mass, function, and gene expression across the entire female lifespan. And across my PhD studies, I've analysed data from around 400 healthy females aged between 18 and 90 years of age, so that I could map the entire trajectory of muscle aging in females right from the start of adulthood to the very end. And so we collected a whole host of measures, including sex hormone levels, whole body composition with DEXA, thigh muscle composition with PQCT, neuromuscular function of the quadriceps, and we've also taken muscle biopsies as well from participants so that we can measure muscle fiber composition and also gene expression with RNA-seq as well. So then with all of this data, we've used a whole host of regression models to look at the associations between estrogen and muscle outcomes at the whole body, muscle and cellular level. And overall, we see that irrespective of age and other important lifestyle factors like protein or physical activity, higher estrogen levels are associated with greater measures of lean mass, including so total lean mass in the body and also muscle mass in the thigh. We also see higher and faster force production in the quadriceps as well, and also fewer hybrid muscle fibers in the vastus lateralis. And when we also look at changes across time as well, we see that greater declines to circulating estrogen across 5 years of aging in females over 50. They're associated with greater losses in thigh muscle mass and hand grip strength as well. So really overall, I think these findings just show us that the loss of circulating estrogen across menopause does negatively impact the muscle from the whole body to the cellular level. And it really emphasizes the need for female-specific therapy so that we can combat muscle wasting in the final decades of female life, because it definitely seems like there are female-specific factors here that are contributing to the muscle aging process. Thank you very much, and happy to answer a question.
Thanks, Annabelle. Great presentation, great timing. And I almost hadn't realised we'd switched to the Deakin presenters with your accent there. Have we got any questions from the room? Emily?
Gorgeous slide, by the way. The question is mainly, do you think the changes in muscle function are driven by structural changes to the muscle, or do you think there's a potential effect of neural factors, either centrally or peripherally?
So that's a really great question. So we actually have a whole host of neuromuscular data we've got from 88 participants that we recruited. And what we saw was that we see an acceleration in the loss of neuromuscular function at around menopausal age, so around 45 years, where that menopausal transition kind of starts. But interestingly, we don't really see that same acceleration in variables that are representative of neural function above the neuromuscular junction. So it seems that the deterioration is happening at the neuromuscular junction or further down from that, like within the muscle.
Great, thank you. I had a follow-up question as well. I didn't quite catch in the presentation, your muscle mass measures, are they MRI or are they DEXA or what are they?
No, they're DEXA. So I've got DEXA for the whole body stuff and then PQCT for the thigh specific measures.
I just wondered if you'd had MRI, maybe it would have been really interested to look at like fat infiltration into the muscle and the kind of the quality of the muscle as well as just the volume, as it were.
Yeah, definitely. We've got like intramuscular fat measures from the PQCT, and we've also done some muscle quality measures with the muscle biopsies as well, so we can actually see fat infiltration like between the fibers. So we've quantified that, and that is also associated with estrogen, but we actually see the opposite association, so increased intramuscular adipose tissue with higher estrogen levels.
So almost like higher intramuscular fat may be good for muscle then.
I'm not so sure.
Yeah, two factors together. Yeah.
Yeah, I'm not sure. I mean, because also fat also can produce estrogen as well, so it could be not quite sure which direction the relationship is happening here. So
Fascinating. Thank you very much.
thanks.
Thank you, Annabelle. So our next presenter from Deakin is Izzy Cotham, and the title of her work is The Development and Validation of a Menstrual Symptom Monitoring Tool for Use in Sport and Exercise. So please start when you're ready, Izzy.
Thanks, Amelia. So most female athletes and exercisers experience menstrual cycle symptoms, and these can negatively impact sport and exercise participation and performance. However, currently there's no valid or reliable method to measure these symptoms in active females. So we aim to develop a valid and reliable tool to assess these symptoms and their perceived impact on exercise. So our methods involved 3 phases. So in phase 1, we generated a list of symptoms from the existing literature. These symptoms were then evaluated by 7 experts through 3 rounds of the Delphi method, and we also had 2 focus groups with active females, and this is what was used to develop a draft monitoring tool. We then further refined this with cognitive interviews with the active females as well. In phase 2, we then administered this draft monitoring tool to 215 naturally menstruating active females. They completed this daily across 2 menstrual cycles. And we also collected We administered other validated questionnaires, such as the Brunel Mood Scale, the Dysmenorrhea Visual Analog Scale, the Premenstrual Symptom Screening Tool, and a couple questions indicative of more severe symptoms, such as the number of health professionals they had seen for symptoms. So then in phase 3, we used the data that we collected in phase 2 to do item reduction, factor analysis, and validity and reliability testing. So the results for this, we had 40 symptoms that reached expert consensus for inclusion even. And after item reduction and factor analysis, the final tool included 26 symptoms, grouped into 6 factors, which were energy and functional capacity, fluid retention and affective ability, positive activation, somatic pain, negative effect, and sleep disturbance. So in terms of reliability, the internal reliability was acceptable. Retest reliability ranged from poor to good. However, we expect this given the natural fluctuations in symptoms across cycle to cycle, and was shown to be valid with higher scores in participants with moderate to severe dysmenorrhea or PMS compared to those with mild or no symptoms. And the tool also correlated significantly with the Brunel Mood Scale and the indicators of more severe symptoms. So in terms of the implications, it's the first validated and reliable tool that's been developed to assess symptoms for active females. And this can be used to identify symptoms and understand their impact on exercise, as well as evaluate strategies aimed to reduce symptoms in active females.
Thank you, Izzy. Well done. Good timing again. Any questions from the room? Yeah, Rowan.
Really interesting presentation. My question would be, how often, potentially per cycle, would you get athletes to actually complete this questionnaire? For example, would it be once a month, once a week, maybe the start and end of period, for example?
Yeah, that's a great question. I think it depends on what you want to get out of the tool. If you were using in an applied setting and you were wanting to monitor your athletes, I think you would want to do it for at least 2 cycles daily across the whole cycle, and then you can actually see if those symptoms they're experiencing are actually cyclical and actually menstrual symptoms, or are they just other noise from other things. And if you do it across the whole cycle and do ovulation testing in the middle as well, it will be able to kind of characterize your cycle a bit better. If you're using it in research and you're only looking at certain phases, like the menstrual phase, you might just want to collect the data on the day you're testing, like during menstruation, or if you're doing premenstrual, for example, just on those days. So I think it depends what you want to use it for.
Thank you.
Thanks, Izzy.
Thank you, Izzy. So I'm now pleased to introduce our next Deakin presenter. So Jeremy Drake is going to present on the effect of exercising skeletal muscle secretions on breast cancer cells. So please start when you're ready, Jeremy.
Thanks, Amelia. So I'm going to present some pilot data from a study that we ran last year, which is a bit more tangentially related to your sports science. We're looking at exercise and its role in cancer care because there's a growing body of evidence that it's emerging as a powerful tool, not only to improve patient well-being, but also to directly modulate the tumor biology. And the underlying mechanism, which seems to always propose to be linking exercise with its benefits in cancer, is the production of myokines, which are secreted factors that are being released from skeletal muscle when it contracts. So when you exercise, the muscle contracts and it releases these myokines. We were focused on one specific myokine called oncostatin M, which was identified back in the 1980s, but has since been characterized as being released from muscle. So it's a myokine. And there are some interesting studies that have come out, one showing that when you add this myokine to breast cancers grown in culture, it reduces the proliferation rate. A rat model of exercise, which was published in 2024, showed that exercise was beneficial in slowing cancer growth and reducing cancer size and prolonging the rat survival. But when you blocked this activity of oncostatin M, all of the benefits of exercise were lost. However, there are human studies which show contradictory evidence. For example, elevated levels of oncostatin M in some human studies have been shown to be correlated with much worse survival, much faster metastasis. So there's different models that are showing different things. And in our model, what we did was we got people to exercise on a bike for 60 minutes at 70% of their VO2, and we took some blood before and after this exercise bout. We looked at the amount of oncostatin M that was in their blood, and interestingly, a lot of the people didn't actually have detectable levels of oncostatin M, but when we could detect it, it was significantly elevated after exercise, which mimics what was seen in that rodent model that was published back in 2024. When we added this blood from our participants directly to breast cancer cells that we were culturing, there was a significant reduction in the proliferation rate using the post-exercise blood after 4 days or 96 hours. But in contrast to that, when we spiked the cultures with pure oncostatin M, 1 nanogram per microliter, that resulted in a significant increase in proliferation rate of the cancer cells. So some of the key takeaways from what we've found so far are that the oncostatin M levels significantly elevate after exercise, but this is variable and highly individual to the participant. And when we add that oncostatin M directly into the breast cancer cell cultures, it elevates or significantly upregulates their proliferation. So what we're doing from here is looking at the mechanism involved, the underlying cause of these changes through proteomics. So if this has piqued your interest, please get in touch. Amelia can put you in touch with me. Thanks.
Thanks, Jeremy. Very interesting. We do actually have a couple of researchers that are looking at this type of area. So if they're not on the call now, then I will link them to Amelia so that you can continue the discussion. Any questions in the room directly? Christoph?
Thanks. I enjoyed that presentation. So would you say oncostatin M has nothing to do with it then in your study?
Well, it's definitely having an effect. It's making the cancer cells grow faster. It's not doing what we saw in the rat model. So the rat model, when they blocked oncostatin M, all of the benefits of the exercise were lost. But the levels of oncostatin M that were detected in the rat model were 10 times higher than the levels that we could detect in the human. And the amount that we could detect in our participants, the amount of oncostatin M we were adding to the cultures, which is based on other cell culture models that are already published, was at 100 to 1,000 times greater than what we could detect in the blood. This myokine is related to interleukin 6, which is known to have a biphasic effect. So at different concentrations, interleukin 6 will have a different effect on target cells. So potentially due to the concentration differences, that might be why we're seeing different things, but I'm not sure.
Great. Thank you very much.
And I'd now like to introduce our final presenter from Deakin. So Monica Kelly is our presenter. So Monica is also a member of our executive for our group, and her presentation is about heat adaptation for females. Start when you're ready, Mon. Thank you.
Thanks, Amelia. Great to be here in the last one for today. So high intensity intermittent exercise as a heat acclimation training protocol is relatively rare compared to continuous exercise. However, high intensity intermittent exercise is likely more specific and possibly beneficial for team sport athletes preparing for competition in the heat. We are yet to fully understand the time course of adaptation to this type of training in the heat, but also the impact of this type of training on objective markers and sleep. And so the investigation here was looking at females and the time course of high intensity intermittent exercise in a heat acclimation protocol and looking at the objective markers of sleep. We had 11 females of trained status complete 6 training sessions across 7 days. The sessions were 60 minutes in duration and had an average exercise intensity of 60% VO2 peak. They alternated repeated intervals of 30 seconds at 90% VO2 peak and 30 seconds at 30% VO2 peak to get that mean 60% VO2 peak. We looked at time course variables. I've only presented some here in session 6 compared to 1, but I'm happy to answer questions related to them. Our sleep data was collected from an actigraph with participants completing sleep diaries, bed and wake time, but also then we looked at a stress and recovery here. We used linear mixed models and bone-friendly post-hoc procedures, and statistical significance was via less than 0.05. We all know that heat acclimation protocol and control factors are really important. So before we get into the results, we didn't have any difference in body mass, USG, fluid consumed during the heat acclimation sessions. Total training time external to the protocol wasn't different between participants. Time of day of heat acclimation training was also consistent. We had no difference in climate chamber conditions, so temperature, humidity, or wind speed. And we were able to verify for all our female participants they were during the follicular phase of the menstrual cycle through estrogen and progesterone concentrations. For the time course perspective, we had our first adaptations at session 3. So we had a reduction in heart rate by 3 beats per minute. But as you can see here on the screen for session 6 compared to 1, a reduction in resting core temperature of 0.18, mean rectal temperature of 0.21, mean skin temperature of 0.2, and 9 beats per minute reduction in mean heart rate. Importantly, no effects on sleep, stress, or recovery for these athletes. So for our female athletes, we were able to identify the time course of adaptation using a high-intensity intermittent exercise protocol, inducing thermophysiological adaptations without incurring disturbances in sleep. So it could be a very beneficial type of heat acclimation protocol for our team sport athletes preparing for comps in the heat. Thank you.
Thanks, Monica. Your presentation location looks a lot more impressive than ours, I have to admit. We've got any questions? Any questions for Monica? I'll do one to start then. You mentioned there were no changes in kind of the fluid intake, hydration status before sessions. What about sweat rate during the sessions?
Yeah.
Were there any changes pre to post?
Yeah, we saw that we had a sweat rate as one of our factors as well. It was probably starting to emerge towards that session 6. We definitely didn't see any adaptations for our females any earlier than that. Our chamber conditions were very hot as well, nice and dry. So we're hoping we were aiding some sweat adaptations happening there, but we didn't necessarily see them in that time course happen any earlier.
Great, thank you. Any other questions? Yeah, Louis?
Sort of piggybacking off Amelia's earlier question, I'm assuming in Australia, you guys have a lot more heat going on. So you guys kind of have the opposite problem that Hannah was having. So how do you know that those adaptations are only from the sessions you're doing and not just training outside on, just with the regular training?
Yeah, awesome question. So this study was undertaken during the winter months of the year. So we had to wait all the way till June to make sure that the temperatures and the average temperatures for the previous 3 months were below at least 25. I think they were even below 18 degrees Celsius. So we had to wait till then and had a very short window to collect all of this data before we then saw the ambient temperatures at the locations where all these athletes were based. We're starting to trend towards where you'd possibly get adaptations just from natural environments. So maybe challenging to do adaptation research in Australia because you have such a small window, but we did ensure that prior heat acclimatization status wasn't there as well as sauna exposure.
Yeah, I was shocked when I learned that it got cold in Melbourne. I just assumed it was warm all the time, but yeah, I was chatting to other people and they told me you do get to single digits during winter, right? Yeah, it's the opposite problem to what we have. Yeah. When you said 18 to 25, it would have been great, Monica, if you could have seen all the faces of the PhD students in the room. They were thinking, if only our summer was like that. Okay, great. I think we're done with all the presentations, so that was fantastic. I just want to say a big thank you to the Melbourne presenters, but also the people from Melbourne, Deakin. I'm assuming you're all in Melbourne, maybe you're not, that have attended, because the time over there is pretty late in the evening. So I really appreciate your effort in engaging with this session. I think there's certainly been a couple of things that have immediately sprung out where potential collaborations may go forwards. And yeah, hopefully when we send that pack to you, you can start discussing with each other directly. Don't feel like you have to copy myself and Amelia in. Please, if something does come of it, tell us further down the line. But yeah, we thought since we've got 10 minutes left, we'd open the room for any questions, because I appreciate there are guests online from Loughborough who perhaps haven't had a chance to make any comments or have any questions. So if anyone online wants to ask a question or make a comment, comments are welcome, or anyone else in the room, then please put your hand up in the room or online.
On the might have been Annabelle's one on, was it
Muscle aging.
muscle aging? So what are your key female specific intervention to combat muscle aging?
Sorry,
Did you hear
I
that?
didn't hear. No.
Repeat it. Yeah, so Louis, who's one of our PhD students, asked, what are your female specific strategies to combat muscle aging that you kind of alluded to? Maybe we need to develop these. What are your thoughts on that?
Asking for my mom.
Yeah.
He's asking for his mum.
So I think really we can think in a couple of different ways. I think firstly, we know that resistance training is really good to combat muscle wasting. That's kind of one of the therapies that is most effective in older adults. But what we see from our neuromuscular data, we see kind of this real acceleration in the loss of neuromuscular function around menopause. It might be that we need specific timing of resistance training, like really emphasize it around that specific age, and see whether that could offset that acceleration in the loss. But we need more research on that. We definitely don't know enough about when that timing could be most effective. The other thing as well is there have been lots of studies about HRT. So when we supplement with exogenous estrogen and progesterone, there is a lot of mixed literature at the moment about how effective that is on muscle mass and strength. Some studies seem to be that it's like it can be effective for muscle strength, maybe not so much for muscle mass. But we definitely need more high quality literature with that, that's kind of more controlled on like how far after menopausal transition are we starting that treatment, how long is the duration of that treatment, and also how much is the dose as well. So yeah, a couple of ideas, but we definitely need a lot more kind of specific research to look at the exact strategies that could be helpful here.
Thank you. Any other questions in the room or online? I have a question for Jeremy. You chose a kind of endurance training model, Jeremy, the kind of 60 minutes, 70% VO2 peak.
Yes.
What factors kind of dictated your choice of that endurance exercise? May there be other types of exercise? I'm thinking high intensity interval exercise that maybe has more of an effect on muscle and maybe perturbs muscle. We've heard about muscle damage today. Resistance exercise was kind of suggested by Annabelle there. Have you considered looking at different types of exercise and how these responses might differ?
Yes, we chose that because it was convenience, because there was already an exercise trial running and we just took blood from their exercise trial. But there are other models that have been published in the last 2 years or so. There's actually a group in the UK who are doing a colon cancer model showing the same things, like the post-exercise blood reducing the proliferation rate. But yes, there are published high-intensity exercise benefits and also resistance the post-exercise benefits reducing the proliferation in culture. So I think now the next step is to understand properly the mechanism that's what is actually changing in a cancer cell as a result of that.
Brilliant, thank you. Any more questions? Any questions from any Deakin colleagues? Oh, sorry, Talia. Yeah, we've got one more from the room.
Yeah, this is Annabelle. Obviously, you mentioned menopause. I was wondering, I'm curious, were you just asking them whether they had gone through menopause, like taking kind of menopause, yes or no? Or also, I'm thinking about perimenopause and how different between individuals. That can be between 10 to 10 years.
did you ask the symptoms before menopause, or is this something that would be interesting to look at in the future?
Yeah, so we did ask a few more questions with sense of like, are they still getting a regular cycle? If it's irregular, kind of how irregular is it? Like, what's their usual length? Are they getting any menopausal symptoms as well? So we had a whole host of those. We asked if they were above 45 years of age. Surprisingly, we only had 3 people that were classified as perimenopausal, which I think probably just comes from difficulty in diagnosing it or kind of assigning it, because of people would carry on taking hormonal contraceptives, so it hides their normal menstrual cycle, so you can't actually see whether they've stopped it or not. So I guess you're kind of more reliant on other symptoms they might get. So yeah, it can be really tricky. We tried to get as much as we can, but I think there's definitely more questions that we can ask, like about yeah, their cycle and everything, and try and get more information of them. I mean, like, some people also had been told by their doctor that they were going through the menopause as well, so that is also another question that we would ask them as well. But if it wasn't quite clear, we would try and work it out by piecing together other bits of information.
Thank you.
So I think we finished there. So again, thank you to everybody who's attended in person today, online. Attending at 8 p.m. Melbourne time is highly commendable. So thank you to everybody who's done that from Australia. Thanks again to the IAS, Kieran and his team, for hosting today. Next Wednesday at 12, the IAS will also host another seminar where I'll provide some information about the work I've been doing here during my visit, my research program. So you're more than welcome to attend if that interests you. So thanks again to everybody. We hope this has been inspiring for you, and that you follow up with people that you've connected with, and that some great collaboration can come out of this.
And I'll just say one final word to those in Melbourne. If you're ever in the UK and you want to come and visit, you're always welcome. Please reach out to me. I'm happy to host you for a day or an afternoon, or a month, I guess.
Evidently. Yeah.
Yeah. Thank you very much.